Hello everyone, my name is Royce. Thank you to be here, and it's my pleasure to be here. Okay, the name of this session is Power in Pairs, how one fuzzing template revealed over 100 IE user-free vulnerabilities. Pairs is the name of the fuzzing strategy we use. First, I would like to apologize that Bo cannot be here today because of the visa issue. And here is a little bit introduction about us. Bo is a member of 557. He discovered vulnerabilities before on Windows Office, Adobe Reader, Flash, and other platforms. And me, my name is Royce, and majorly focus on Windows internal, malware, and exploit detection. This picture is from the OSVDB, and we started try to find IE vulnerabilities with fuzzing around 1 year ago. And you can see from this picture, this picture is number of the CVE disclosed by Palo Alto Networks. It starts growing after we began our IE vulnerability hunting. In the very beginning, we think if the result of the CV number can reach like dozens, we will be very happy. But in the end, it reaches over 70, like a basketball game score. So we are very excited. Today, we would like to share the fuzzing strategy we used and how we did it in detail. Okay, fuzzing. For many people, it's simply a testing techniques. You run a lot of samples on a large number of machines and hope it can generate some useful dumps and try to find vulnerability on those dumps. This high-level concept, while correct, actually overlooks many hidden details of fuzzing. What is the most important factor of fuzzing? We think it is not machine. We think it is not how long we spend on fuzzing, because we don't have 200 or 300 machines. We don't have 5 years or 10 years to do fuzzing. So we think the core problem of fuzzing is how to generate high-quality test cases effectively. High-quality test case means less garbage and more useful crash, more vulnerability. So we would like to attack this problem, but first of all, we need to solve one thing: how to describe a web page for a case generation purpose. You know, there are many things on a web page, like attribute, tags. So we ask ourselves a question. Is it possible to design one web page template that can describe and cover most cases? The value of this universal template is that it can greatly reduce the complexity of test case generation. So we study many zero-day samples, we study daily browsing web pages, and we study MAPP POCs. And we conclude that most of the web pages with Internet Explorer vulnerabilities can be described as the following template. In the beginning of template, we have a compatible meta tag. Compatible meta tag indicates which version of the IE you would like the web page to render as. Like IE5, emulate IE7, IE8, IE9. They are slightly different between each version. Then we have CSS part. CSS describes the look and formatting of a web page. Then we have script function. Here we use JavaScript. It can dynamically change the web page content. We also call this part dynamic part. And in the end, we have static part, which is HTML. And usually we will assign one function from assign functions from the dynamic part to the event of the static part. Like here, we assign a fast 0 to the unload event. So fast 0 can be triggered while this page loading. So this is it. This is the template that can cover 99% of the cases. Theoretically, we can discover almost every vulnerability by this template. But in fact, it is impossible because combination explosion. How long it would take to enumerate all the combination of the HTML plus JavaScript plus CSS plus compatible information, it will take long time. So adding some randomness is an approach to solve this problem. Some randomness is necessary to help us to construct test cases that is nearly impossible to conceive. Because web page that is easy to conceive may be already tested by the QA, which means no problem. But randomness also has some drawbacks. There are at least 2 points of the 2 problems of the randomness. The first one is how random is our random? Does it repeat? If the random method is no good, sometimes we will generate duplicate test cases, so it is waste of time. And we also notice that we have an array of machines, and actually some of the machines they are executing similar test cases or the same test cases, which is also another waste of time. The second problem is we cannot track the relationships between statements. If we simply generate test cases randomly, the relationship between each statement sometimes very weak. Sometimes the whole test case becomes a garbage. So we would like to enhance the relationship between the statements. We want to guide the randomness. We need directions. But how to do it? How to guide the randomness? One day, one thing happened, and this experience gave us an idea how to guide the randomness. One day, Bo's wife asked him to repair her broke iPhone screen. Okay, as you know, Bo is a great hacker, so he's a good hacker. He's very good, so he should be no problem, no sweat. Okay, he almost did it. But after he replaced the screen, we found 2 more screws on the table. Those screws should be inside the iPhone, but they are on the table. So something goes wrong. And we turn it around, we cannot find the camera. Camera is missing. And the worst thing is this iPhone is dead. We cannot turn it on. All right. So what we learned from this story, things learned from this experience is maybe engineers are not good at repairing things. Just maybe. And maybe engineers make mistakes taking things apart, like undo things. And maybe engineers make mistakes putting things back together, like redo something. And most importantly, we think this assumption probably also applies to the IE engineers. Okay, so we have a very rough idea, trying to do something, then undo something. So maybe there's some reference, will trigger some reference issue, user after free issue, or maybe we try to redo something. We can trigger some issues. Okay. Let's describe this idea in flowchart. In first stage, we do something first. Then in second stage, we do something else randomly. And in final stage, we do something contrary to the first stage. Or we can initialize a status to a value A, and we do something else. And in the final stage, we assign that status to value B. Okay, we call this idea pair. Once we have this idea, we started to build our own fuzzer. The first version of our fuzzer, actually, we do it very easy, in a very easy way. There are 3 objects can execute commands. Execute command is IE only. We can execute various commands on 3 different kinds of objects. The first one is document, and selection, and range object. We can execute commands on this object, then execute an undo command. That's it. There are many interesting commands we can try, like we copy something, then undo. We delete something, then we undo. We refresh, we insert a button, then undo. And very effectively, we found something through this way. And the second thing we tried as a pair strategy is we try to manipulate content. Here's a very simple example. First, we save inner text to a variable. Then we clear the content through this method, write with an empty string, clean everything. Then we assign the content back to the inner text. This is just an example. There are many other ways to manipulate content. And this method also very effective. Okay, this is the first version. And naturally, we would like to expand this idea, pair, this concept. We would like to take one more step. So we have a second version of fuzzer. We simply went through the whole spec, MSDN, and pick up interesting property and method. Property that we assign a property with value A, then assign it with value B, that's a pair. Or a method, we assign it with parameter A, then parameter B, that's another pair. Or 2 methods, they are doing contrary things. That's method A and method B, that's a third pair. We collect those pairs and save it into a list and randomly pick pair from that list and put it into the template and fill the rest part randomly. Right. So this enhancement also doing well. Then we extend pair further. We have third generation of the pair. And in this version, we divided pair into 4 different types. The first one is the explicit pairings. This pairing is very straightforward. Just do something on or switch to off or assign to value A, value B, or calling a method. Very straightforward. And the second type of pairing is doing pairing implicitly, which means we try to manipulate something that maybe not defined on the spec, but also very important while page loading, page rendering. Something like DOM tree relationship. We swap the parent-child. Or there are 2 pages, we navigate between those 2 pages. That's also a pair concept. Okay, the third type of pair is hybrid pairing. I will explain this type of pairing in detail later. And the fourth one is pairing combination. We simply mix them all together and use multiple pairings per page. Okay, I will explain each different types in detail and give you a few examples. For explicit pairing, like I said, we change something very straightforward. For example, here we have a.style.display. We change it from block to none. Block means we render this object as a block element. Then we change it to none. None means do not render it. It become invisible, so which will release something. We'll let browser try to release something. This is a pair. This is an example for the property. Okay, an example for the method is 2 methods doing contrary things, like b.focus, then b object will get focus. Then we call b.blur, and then B will lose the focus. And commands are very interesting. Here, the first example is we indent an object, then we outdent the object. Or we can select all. We can execute a select all, then we execute an unselect, which let browser very busy. Okay. And the last example for the explicit pairing is we register two different purpose events. Like we can register on focus in and focus out and doing something different in each event listener. Okay. The following example are all patched or fixed by the Microsoft, and these examples are not reported by us. So I think it should be okay to present here. Okay, let's have a look here. And the pair here we use is focus in and focus out. This script is very simple. In this line, we call a focus. So focusing will be invoked. And in focusing, we create a new body object and replace the old one. So while the old one being replaced, the focus out will be triggered. And we will execute a document.write to clear the document content. Okay, here's another example. The pair we use here is indent and outdent to move object. First, here we have a list here. In static part, we have a list here, and we have a button here. And during unload, we will invoke this function. And during this function, let's ignore here first. We will execute an indent. And this indent actually will trigger the unresized event. And during this event, we will execute an outdent. Then we clear this object, the text, clear it to 0. And for some reason, this unresized will be triggered several times and cause a reference count issue. And in the end, while we execute a select all, okay. Now I would like to talk about implicit pairing. Implicit pairing means we trying to manipulate something that is not property, not method, not attribute, but also very important for a page. Something like a content. We already have an example. We can manipulate content through the inner text or through the document.write with an empty string. Another implicit pairing is manipulate the DOM relation. Like we can swap the parent node and child node. We can append a node, apply an element, remove child. There are many things can do. Or we can change the web page status. We can navigate from page A to page B, use window.navigate with a URL, or through location.hrefs to another page. Okay. The implicit pairing we use here is we change the DOM relation here. Start from the static part, we have a table here. The ID is BH1. Then we have a BH2 and BH3. BH3 is a TD. Then very simple. We simply use BH1.apply element to change the BH3 become the parent of the BH1 and trigger the problem. Okay, the third types of pairing is hybrid pairings. We found that if we only fuzzing in the dynamic part or only with DOM tree, only on the DOM tree, then we will only find vulnerability related to dynamic part. So in order to increase the coverage, we need to add the static part. So our fuzzer will also cover the static part fuzzing. Something like we will assign an attribute at the static part randomly, and then we change that attribute in the dynamic part, which means we change one thing from two different parts. This concept can also use like we change a property with a statement, then later we change it again with a method, which also change one thing from two different parts. So that's the meaning of hybrid pairing. Okay. This is an example. First, we change an attribute with a statement. Then we change it again with a clear attribute. We simply just clear it. Here is another example. The pair here is we set content editable to true in static part. Then we change it to false in the dynamic part. Here, static part, we have a table here and caption. And during unload, we will execute a command select all here. And this select all will trigger static part onSelect start, which will clean the inner HTML of TTT, clear the HTML here. Later, we use a collect garbage to force trigger the problem. Okay, this example, the pair is we execute a command, we execute a select first, a method, then we execute a command to onSelect. Okay, this example, when we execute a select, it will trigger the onSelect event here, event callback here, and BH2 will try to swap a node, and this action will trigger BH0 on property change. Then we execute the onSelect and trigger the UAF problem. Okay, the last one is pairing combination, which means we combine multiple pairs all together in one template. Here we can see the pair here is style. Here we have we change two style here, and we assign two style here first. Let's go through this example. In static part, we have a form here. The ID is BH0. And we set BH1 is style to overflow equal to visible. Later in the dynamic part, first, we change the BH1.style.overflow to auto, from visible to auto. Then we change the BH0.style.display to none, which means do not render this object. And this one will trigger a unresized event. Then we will execute a document.body.removeChild to remove the BH0, mess up the whole DOM tree relation. Okay. So how we construct the test cases? So we build a list of pairs, explicitly, implicitly, hybrid, and combination pairs in a list. Then we randomly insert these pairs into the template. Like if we feel here and here can insert a template statement, then we insert the first statement, plus means the first statement, minus means the second statement here. Or if we feel we need a static part and dynamic part pairing, we will insert here and here. This is how we build a template. So let's see a demo, how it looks like. Here's a template. In the beginning, we can pass the compatible information here. And then we have CSS part. And later on, we can randomly register event here. And we can insert the predefined pair here and try to trigger the event later. Also, we will generate static part here and assign it with ID. And event callback is also generated here. Pair configuration file. From here, you can see the pair number. We guide the randomness. We guide random to randomly change the direction property from right to left to right. This is the first example, and we have many here. Okay, let's run the program. So this is how it looks like while fuzzing. Okay, that's it. Okay. Okay, now I would like to talk about the implementation detail. We don't use any script. We don't use Ruby. We don't use Python. All of our implementation is in C. And we have 20 VMs and 1 master server. 15 VMs is for routine fuzzing, and 5 of them is for experimentation because we always have new idea or new pairings we would like to try. We will run on those experimentation VMs. We have a so-called 1 million sample rules. If we have a new idea, we will run it. And if after 1 million samples, there's nothing interesting, we didn't find anything interesting, then we will stop. Probably that direction is wrong, and probably that module we try to fuzz is very robust. So this is our rule, 1 million rule. And we have 1 master server to collect and analyze all the results. Okay, we will enable the full-page heap verification for IE, so it will be much easier to get the crash. And once crash, we will save the web page immediately, and we will also save the crash dump at the same time. And third thing to do is we will try to reproduce the crash again at local because there are many root cause for a crash. So if it will crash again, we think it is very stable. So we will upload the sample along with the crash dump to the server. And server will save those samples and dumps according to the crash address. So all the dumps crash at the same address will be saved under the same folder. We only need to look at 2 or 3, then we can then we know if it is worth to go deep to look further. Okay, here's the result. So far we have 8.1 million crashes samples, and there are over 400 unique crashes. There are 150, we think, exploitable bugs. And why there are 400 unique crashes, but only 150 exploitable bugs? Some of the crashes, they are not exploitable, and some of the several crashes may point to the same root cause. So we think there should be 150 exploitable bugs. And we already report 106 bugs to the Microsoft. 5 are considered duplicated and 4 was rejected. So far, we got 71 CVEs. And this CV affecting from IE6 to IE11. Okay, future work. So far, we only challenge IE, but we think maybe Chrome and Safari are worth to try. And PDF, we can also run Flash JavaScript in PDF. So maybe we can also use Pair to fast the PDF. And Flash, we can run ActionScript. So maybe Pair can also help Flash fuzzing. Okay. Be so fast. Okay, we would like to thank Yamata Lee and Wu Shi, provide many valuable information, and Anthony help the whole fuzzing structure. Okay, so Q&A. Yes. Thank you. Excuse me? The question is, do I publish? Will I publish my code? Probably not. Probably not. And if actually, if you use the same code, probably you will find the same bug as us. Yes. So yes. So we think the better approach is you understand our concept, you understand our strategy, and maybe you can add your own idea into it, and maybe you can find new bug. Yeah. For our team, yeah, we the first time we built a fuzzer, we don't look cross fuzzer, we don't look grinder, because we don't want to build something like LAN. We don't want affect by their thoughts. So we build our own things from scratch. So I would suggest you can take the idea and build your own fuzzer. Yes. Okay, the question is, was it only user after free bugs I found? And we found a few double free bugs, but very few. And most of the bugs are user after free and type confusion. Yes. Okay, so the question is, will isolate heap and the memory protection patch from Microsoft affect the fuzzing? Okay, so yes, it will affect the fuzzing, but they are defeatable actually. And for memory protection, that mechanism actually covers many user after free bugs. Microsoft starting to reject those bugs can be covered by memory protections. But we think if one day a method can bypass the memory protection, then those bugs will resurface again. Yeah, and isolate heap also can be defeatable. Yes, but they are also affect our fuzzing. Yes. Okay. So thank you.